Welcome viewers, this is Mr. Dingo and I want us to continue with our lesson of last time, that was integration. You remember last time we talked about the process of integration. Then later on we talked about both the definite and indefinite integrals. We also learned how to get a function if you have the coordinate of one point at least where the curve is passing through. Now today we want to look at areas where integration are applied, and we are going to look at the methods of finding area under curve. Now briefly I want to explain here what we have here. We know this is a sketch of a diagram where we have the upper limit is b and the lower limit is a. Here is the function y equals to fx. We know that fx can be anything, could be x squared or any particular function there. Now you realize that when you get area using integration, you're actually getting the exact area, the actual area. We know that in the previous chapter we talked about area approximation, where we looked at counting technique. Also we looked at mid-ordinate rule and also the trapezium rule. But those methods were used to estimate. They were methods of estimation or estimating area. So today we want to look at the method to get the actual area or the exact area under curve. Now if you are looking for the area under curve, especially if the curve is positive, what I mean by positive, it means it is above the x-axis, where region area is the area we need to calculate, then we are simply going to use what we call the definite integral to be able to calculate it, where if you have the area here which is bound by the curve y equals to fx, the x-axis, the line x equals to a and the line x equals to b, meaning the region here, it is bound by four things. One is y equals to fx, another one is the x-axis, x equals to a and x equals to b. That one is given by the integral of the function y with respect to x within the limits a and b, and that's what you have given here. Where y here is, you put the function, what you have given to you in every question there. Now that's what we need to do basically. There's not much. If you understood how we dealt with the what we call the definite integral in the previous lesson, then this one will easily be understood. Now if you know a function like y equals to x squared, and you know the limits, the upper limit and the lower limit, and also the x-axis is known as there, very easily just use the definite integral form method that we learned last time, is what we have here, then you will be able to have your area. So I want us to give an example. So that we can see how to get this area under curves. Now we have example 1 here, and you can see it says find the exact area enclosed by the curve y equals to x squared, the x-axis, the lines x equals to and x equals 4. You realize that the curve is this part here. Another line bound enclosing this area is x equals to 2 to this line here on the x-axis. Then we have this boundary is x equals to 2 and x equals to 4. So we need the area which actually have shaded there. Now for us to get that area, we know that I said that the formula for getting area of an enclosed part is this is b a y times dx. Now realize that we can transform what we have here to what we have here. The limits for b is 4, a is 2. So I'll say area here will be, this will be 4, 2. Now the value of y here is x squared. So I'll say x squared dx. So after we get this one, we can the first thing we are told to integrate. So we are going to integrate by saying that after integration, obviously we'll have a bracket. If you integrate this one, we are going to have x squared plus 1 over 2 plus 1. But remember that right now I don't want to include c, because whether include C or I don't include it, after subtraction that C will disappear. So I'll simply ignore that C and say this is what we have, and we have here 4 and 2 here. So I'll say here, if I simplify, I'll say x cubed over 3. That is what I have. So if I move forward to now work out this one, we know that now we substitute 4. So it will be 4 cubed over 3 minus 2 cubed over 3. So I know that if I simplify this, 4 cubed should be around 64. 4 cubed is 64. Divide by 3, divide by minus 2 cubed is 8 over 3. So 64 minus 8 is 56. So you can have 56, 6 out of 3. 56 out of 3. In improper fraction or in a mixed fraction, it will become 18 and 2 over 3 square units. This is the area of the curve, be bound by the curve x, y equals to x squared, x-axis, the line x equals to 2 and the line x equals to 4, which is this region here. Realize what I've done simply is to integrate, and something to note here in this, where y is, I've substituted the equation there, and then what I've also done here is to ignore c. The reason why I'm not including c is because we know from a definite integral that we did last time, during subtraction, it's still in this level here, c will simply eliminate itself because it will be c minus c. So in this particular area, you are allowed to ignore that c when you are moving on. So this is the area of this particular, the answer for this particular question. Let us move to example 2. And example 2 reads, find the exact area R. This is our area R, the region that is shaded, enclosed by the curve y equals to 20 minus x squared and the x-axis. We know that now the limits here are -5 and 4. So -5 and 4 will be our limits. Now sometimes in exams you may not actually be given those limits. So if you have the equation and the curve is like this, you just have to ensure you get the x-intercepts. That's where the curve cuts the x-axis. You will be able to locate these particular points. But for now, let's deal with them the way they were. So first of all, I'll say area is given by the integral b a y dx. So if I try to bring in what I have in this curve here, I will say area will be, the upper limit is 4, the lower limit is -5, and the curve is 20 minus x squared, put that in bracket, dx. So if I have this one here as the instruction to integrate this one, I'll move ahead to integrate. We'll say after integration, I'll get a bracket. 20, we know that 20 is the same as 20 x power 0. So plus 1 over 0 plus 1. Now I'm trying to give you all the details, but now since you know how to integrate, you can simply move very fast to the next step. But now I'll be able to go slowly because I know there are learners who really want to see what we are doing. So x is the same as x power 1. So to integrate, we add 1 and then we divide by 1 plus 1. Then minus x squared is x2, we add 1, then divide by 2 plus 1. This one in bracket, and then we say this is 4, -5. Now viewers, you realize that I'm still continuing to ignore c because we know what c will happen to c. It will simply self-eliminate. If I move forward now, let me simplify. This will be 20x, if I simplify, minus a half, because this is 2. 1 plus 1 is 2, but there's 1 here, so I'll say that's a half x squared minus, this is 2 plus 1 is 3, so minus a third x power 3. Put bracket there. Remember that we could move directly to this step from here to here, but I'm trying to give this step here so that those learners who are picking up with us right now, or those ones who are trying to see in details what we are doing, can actually understand. So from here we are substituting the upper limit in the semi-fraction, then we subtract the same value when we substitute the lower limit. So I'm going to say this is bracket 20, upper limit is 4. Let me use this kind of bracket, minus a half into 4 squared minus a third into 4 cubed minus, I subtract, let me write that other value down here, it will be 20 into negative 5 minus a half into negative 5 squared minus a third into negative 5 cubed, close bracket. Let's come up here. Now 20 times 4 is 80. 80 minus 4 squared is 16. 16 divided by 2, 16 times a half is 8. Then we know that 4 cubed should be 64. Let me see. 64. So 64 times a third is 21. That is 64 over 3. So 64 over 3 minus 64 over 3. Because I'm trying to move very slowly so that we move together. Minus, let's come here. 20 times negative 5 should be negative 100. Minus negative 5 squared is 25. Over 2 should be 20. 25 should be 25 over 2. Minus negative 5 cubed. Negative 5 cubed should be minus 125. Negative 5 cubed. Negative 125 times negative a third should be negative, should be plus. Because we have negative a third times negative 125 should be 125 plus over 3. That's what we have. So let us see. We have 80 minus 8 minus 64 over 3. So we have 80 minus 8 minus 64 over 3 minus 64 over 3. We get 50 2/3. 50 and 2/3 minus. We have minus 100. So minus 100 minus 25 over 2 plus 125 over 3. I get minus 70. 70 and 5 over 6. So that's what we have. So viewers, we know that this is minus, this minus. So what we are going to do, we are going to subtract. And we know minus will be positive. So it will be 50, 2 over 3 plus 70 and 5 all over 6. So that will be 50, 2 over 3 plus 70, 5 over 6. We get 121 and a half. 121 and a half, or 121.5 square units. Now viewers, I tried to use a calculator to work out this one, but believe me, there's no big deal here. If I were to do it manually, I would just say 50 plus 70. 50 plus 70 separated plus 2/3 plus 5 over 6 also separately. So 50 plus 70 is actually 120 plus LCM is 6. 3 comes into 6 2 times. 2 times 2 is 4 plus 5, 6 comes to 6 1 times. 1 times that is 5. So 120 here plus 9 over 6. So 120 plus 9 over 6 should be 1 and 3. 3 over 6 is the same as a half. So 120 plus 1.5 should give you 121 and a half. So at this level in Form 4, you really don't need these very much detailed steps. You just need to go work here because you are given a calculator, you can simply be able to move very quickly. So this is our answer for question 2. Let's move to when we are getting area below the x-axis and see what will happen. That's example 3 now. Now viewers, we have looked at previous examples, example 1 and 2. We have looked at how to determine the area that's actually above the x-axis. Now in this case, you want to look at the area below the x-axis when the curve actually goes below the x-axis. And in this case, this region here, let me label it region R in our example. Now if you have an area which is going below the x-axis, for whatever reason, like in this case here, when you calculate it, you realize you are going to find that the value you get, the answer you get finally is a negative answer. Now, when you get a negative answer as a result of attempting to calculate area, that is a sign enough that that region you are actually trying to calculate is below the x-axis, like in this case here. You see this is the x-axis and the region you want is below. Now we know that area cannot be negative, so if you find such particular problem, you simply calculate, get that negative answer, and then what you do to get the final answer that you are going to write as the area is write the answer without the negative. So if you got negative 10, the area will just be 10 because area cannot be a negative number. Now we have an example here, which is the first example under this case, but the third example of our area of getting area. So what we are going to do here is to, first of all, write our instruction. What are we going to do? We are going to find the area, or we know this is the formula or the instruction on what we should do, y dx. But now in this case we know what this means. We can say the function here is the upper limit is 3, the lower limit is 0, 0 to 3. And the curve is this way, but I want to expand it. This curve can also be x squared minus 3x. So I can also just write this one down here by saying this is x squared minus 3x. We have to integrate that with respect to x. So once we have that, the next thing we need to do is to actually integrate. So when we are integrating, we are going to have bracket. When you integrate this one, x squared, it is going to be x power 2 plus 1 over 2 plus 1. Then minus 3x. X is the same as x power 1. Then we add 1. And then we divide 1 plus 1. This one here, when the upper limit is 3 and the lower limit is 0. I said we don't need C. We don't need to include C. We know what will happen to it. And I said that this step here is not very necessary right now, because if you know how to integrate very quickly, then you have just go to the next stage that I'm writing now here, which is x a third, because this is 2 plus 1 is 3, so there's 1 here. A third x cubed minus, this is going to be 3 over 2. So 3 over 2 x squared. I have that. The limit is 3, 0. Then the next thing I do is to substitute. I know that when I substitute, the lower limit is 0. So it means I'm going to have, when I substitute, 3 minus 0. Let me just do it and see. This is a third into 3 cubed minus 3 over 2 into 3 squared. 3 squared. Then we subtract a third into 0 cubed minus 3 over 2 into 0 squared. So I want to believe that this one will give us 0. So I don't have to really struggle with it. I'm just going to work on this other side. So this is 3 cubed is 27. 27 over 3 minus. This is going to be 3 squared is 9. 9 times 3 is going to be 27 over 2. I know that I will simply have minus 0 on the other side. So 27 over 3, 27 divided by 3 should give us 9. So we'll have 9 minus 27 over 2. 27 divided by 2 is 13.5. So if I subtract that, 9 minus 13.5 is negative 4. Negative 4.5. But viewers, we just said that if you have negative 4.5 as the answer, what that tells you is that that answer is actually below the x-axis. So for us to get the actual area, and area cannot be negative, we simply ignore the negative. So the final answer will be 4.5 square units. Let's go to an example where in one question we have part of the curve is below the x-axis and part of the curve is above the x-axis. Now example 4, we have the diagram below shows a curve of the equation y equals to x into x minus 1 into x plus 3. And you can see the curve here. This is the curve. Obviously it's a cubic curve, that's why it's forming a wave. Then you see that we are asked to determine the coordinates of A and B, hence determine the area of the shaded region. So A and B are actually the intercepts, but we know there's a third intercept here. So it means that if we are looking for these values, we are going to find a range of 3 values. And we are lucky that the curve already is given to us y equals to x into x minus 1 into x minus plus 3. Now we know that when we are dealing with this particular case here, we know that we said earlier in our earlier lessons, especially in differentiation, that the x-intercept, the value of y is 0. So y should be 0 at x-intercept, meaning at the point where the curve intersects the y-axis. Now I don't have to expand it first. What I'm going to do is to just say if I have y here, y should be 0 at x-intercept, that should be equal to x into x minus 1 into x plus 3. Now we know that these numbers are multiplied. X is multiplied to x minus 1 is multiplied to x plus 3. It means that one of these numbers is 0. So we can say therefore x is 0, or x minus 1 is 0, or x plus 3 is 0. So from here I can say x already is 0 here, or x is 1, or x is negative 3. So already have the values of x at this particular point. Now we know that x is 0 is here. This is where it is. X is negative 3 must be here because this other side is the negative 3. So we can say this is negative 3. then x1 should be there because it's positive. So what I'm going to say, the coordinate here, coordinate A, which is here, should be negative 3, 0, and B should be 1, 0. Now we have dealt with that first part. The next part now, in fact, by dealing with those parts, we have gotten the limits. But you realize that we have two parts of region here. One part is above the x-axis, the other part is below the x-axis. It means we cannot just do differential integration by simply assuming that the lower limit is negative 3 and the upper limit is 1, and we calculate 1. So that way it's going to give us a wrong answer. So we have to deal with this part separately. Let me say area A and area B. So we have to get this area separately, and this area A, the limits are negative 3 and 0. So the upper limit is 0, the lower limit is negative 3. For area B, the upper limit is 1 and the lower limit is 0. Once we get area B and area A separately, then we add them. That is what we are going to do. So first of all, we know that the function for both A and B is the same. Let us now expand or open up the function so that we can be able to work with it. And y, we have said, is equals to x into x minus 1 into x plus 3. So if I expand this one, I say y equals to x squared. Let me just do step by step. Minus x into x plus 3. Again we expand, so that will be x into x squared minus x plus 3 into x squared minus x. Y here will be x cubed minus x squared plus 3x squared minus 3x. So we have y here will be x cubed, negative this one, but this one should be plus 2 x squared minus 3x. So we have got our function in expanded form. This one is what we have up there. So what we need to do here now, we are going to look for area A. So area A should be the integral of the upper limit is 0 and the lower limit is negative 3. And I know I will take the function which is here, x cubed plus 2x squared minus 3x dx. So if I do this, and right now I want just to go directly, so please let's jump one step now. We know that when we are integrating this one, we'll have 3 plus 1, then divide by 3 plus 1. So it will be x power 4 over 4 plus, let's add 1 here, so it's 3 there, then divide by 3, so it will be 2 over 3 x power 3 minus, let us have 1 there, so 1 plus 1 is 2, so it will be 3 over 2 x power 2. This should be 0, negative 3, sorry. So moving forward, we substitute, and I know that when I substitute 0, I'll just get 0 minus. So I'll say this is 0 minus, because when I substitute 0 here, everything will be 0. Minus, let me have bracket, this is negative 3 power 4 over 4 plus 2 over 3 into negative 3 power 3 minus 3 over 2 into negative 3 squared. So viewers, I want you to appreciate that I've just put here 0 because the whole of this one, the upper limit will give us 0. So I move forward by saying negative. So negative 3 power 4, negative 3 power 4 should be 81 over 4, 81 over 4 positive, plus we have negative 3 cubed is negative 27. Negative 27 times 2, then divided by 3. That's negative 18. So this one will be minus 18 minus 3 squared is 9. 9 times 3 is 27 over 2. So this will be negative, in bracket, 81 divided by 4 minus 18 minus 27 over 2. We get negative 11 and a quarter. So negative 11 and a quarter, negative times negative will be positive. So finally we get 11, positive 11 and a quarter. That is the area of A, the first part. So we are moving to the second part of this curve, and the second part is going to be, like we said, the same function here. In fact, I can carry it up to here, because the integral of this one is the same for both of them. So I'm just going to change the limits here by saying now area B, but let me just show it so that students don't have a problem. 1, 0, and it is going to be x cubed plus 2x squared minus 3x dx. So we know that if we integrate this, we get this. So we'll get finally here, that is x power 4 over 4 plus 2 over 3 x cubed minus 3 over 2 x squared 1, 0. So viewers, you see we have gone up to that part. So the next thing that remains, let me get some space here. The next thing that remains here, if we carry that one up here, is to substitute. But again, we know that the other side, I'm just going to have, if I substitute, I'm going to have the value there is now 1. So 1 power 4. 1 power 4 over 4 plus 2 over 3 into 1 cubed minus 3 over 2 into 1 squared. I know, just like I said, I'll subtract 0. Why will I subtract 0? I'll subtract 0 because the lower limit here is 0. So if I substitute 0 here, all these variables will turn to 0. So I don't have to struggle with that part here. Again, so what I'll go here, 1 power 4 is 1 over 4 plus 1 power 3 is 1. So this is 2 over 3 minus 1 squared is 1. So 3 over 2. So if I do that, I'll get 1 over 4 plus 2 over 3 minus 3 over 2. I'll get 7 minus 7 over 12. But we said that if you have minus, it tells us that this one here actually is below the x-axis. So what we said with that, we actually ignore the negative. So the area is 7 over 12 square units. Square units. So we have got the area up to here of B, and we have got the area of A up to here. Square units is there. So what we need to do is to add them. What we do now to get the total area is to add them, which is going to be 11 and a quarter plus 7 over 12. And if I do that, 11 and a quarter plus 7 over 12, I will get 11 and 5 over 6 square units. So viewers, this is the final answer of this particular problem. You realize that if we did this thing directly, if we just integrated here and substituted -3 as the lower limit and 1 as the upper limit, we could not get this particular answer here. Probably we'll get the answer where this one is subtracted from this, which means it will be an answer which is much more lower or maybe added. So that is one issue that we need to really understand. If you have two regions, separate them, work them separately, and you realize that if you get the value of A put aside, you go to B, you put aside, you see things more clearly because you don't bring all the ideas together or all the parts together. When you bring them all together, it becomes bulky, more complicated, and chances of you making a mistake are very, very high. Now we have seen how to get the area under curve between below the x-axis, above the x-axis, and a mixed equation which is above and below in it, like what we have just seen here. Now I want us to go to a more complicated examples which may involve other shapes like triangles and trapezia, especially when you are talking about a curve and a straight line, both in the same graph. So let's go to example 5. Now we have to deal with example 5, and now we are not dealing with the area between just x-axis and curves. Here now we are dealing with the area between curve and a line, a straight line. So you can see we have the straight line here, y equals to x. That's an equation of a straight line. Then we have the curve. So you see the line here and the curve is here. So we want to get the area between them here. You realize now we don't have this one playing a part here, but it's still going to play a part. Now you realize that well, if you look at this curve here, there's a point where these two lines are intersecting. It is very important for us to determine the coordinate of that part, because it is from that coordinate we are going to find the limits of this particular working out. So if I drop a straight line coming here, and let's say this coordinate, this value here, coordinate here may be in coordinate P, assuming. So that's our coordinate P. You realize that if we divide this line, bring it here, there's a region of an area appearing here, and this area is a regular shape, which is a triangle. And if it's a triangle here, the area of a triangle can actually be length times width, which will get me this area here. But if I get the area under the curve, y equals to x into 4 minus x, from O to this particular point here, let me name it x, I know that the area under curve will cover everything. It will be area under this curve, so meaning it will be here, including everything here. So for me to be able to now calculate the whole area, I'll get the area under curve, all of it, minus the area of a triangle in below here. That will give me the area that I'm looking for here. So it means that I cannot get the area of the triangle, I cannot get the area of this without the value of x here, which is actually going to be obtained by the coordinate of P. But you realize that at P, y equals to x and y equals to x into 4 minus x form a simultaneous equation, meaning they share coordinates at that particular point. So I can say at P, y equals to x and y equals to x into 4 minus x are simultaneous. Simultaneous equations now. So if they are simultaneous equations, we can therefore say if we have y equals to x, but y is x into 4 minus x, then it means that the value of y, x here, so where y is, I can actually bring in x. Then I say x will be equals to x into 4 minus x. So if I open bracket, I'll get x equals to 4x minus x squared. So I realize that if I bring this x here, I'll get 0 equals to, this will be minus, it will be 3x minus x squared. But you know I can factorize x, so I can say this is x into 3 minus x, meaning either x is 0 or 3 minus x is also 0. So here x is 0 or x equals to 3. So I have the two values of, this is 0, I have the two values of x, and if I have the two values of x where these 2 points are meeting, they are meeting here, they are meeting here where x is 0, and they are also meeting here where x is 3. So if you have the value of x there, but we have also been told x equals to y equals to x, it means that but y equals to x, so it means that y is also 3. So the coordinate of P, our coordinate there is 3, 3, and our coordinate here should be 0, 0. So this is 3, 3. So once we have that particular point, what I can say therefore is that this value here is 3, and our perpendicular height here is also 3. So I can get the area of this triangle here, and I know the area of the triangle, so area of triangle, and the area of triangle here is also the same as the area under the straight line, this one. You can still get it by integrating, but now that is going to take more time. So this area of triangle is a half BH, which is equals to a half times 3 times 3. That is actually going to be 9 over 4. 9 over 2, sorry. 9 over 2, which is the same as 4.5 square units. Square units. That is the area of this triangle here. Now I want to get the whole area, from area under the curve, which is going to be everything, including the area under the triangle, and that one cannot be calculated by any method other than integration. So area under curve will be, we integrate with the limits 0, 3. So the upper limit is 3, 0, and this will be, the curve is y equals to x into, if I open bracket, will be 4x minus x squared dx. So if I integrate here, if I integrate, what I'm going to get is a bracket with 4x squared over 2. So what I'm going to do here is that x here 1 plus 1 over 2. So let me just go direct, 1 over 2, because I will have 2 as the power 1 plus 1 over 2. So 4 divided by 2 is 2, x squared minus, let's come here, 2 plus 1 is 3. So x power 3 divided by 3, there is a third, x power 3, limit is 3, 0. So I will say that this is 2 into 3 squared minus a third into 3 cubed. Let me have this bracket minus 0. Why am I putting 0? Because this one is 0. So anything I substitute here, subtract the other side, will be 0. So I'll simply leave that one there. So this one times that is 9. 9 times 2 is 18. Minus, this is 3 cubed is 27, divided by 3 is 9, so minus 9. So what I'll do here, the answer here is 9. So it means the area, the whole area under the curve is 9. But we know the whole area under this curve carries both this and this. So what we need is to get this one only. Let me label it R. For us to get R only, we are going to get the area under the curve, the whole area under the curve, which is here, minus the area of this triangle, which is here. So we are going to say now area of shaded region will be 9 minus 4.5, which is actually 4.5 square units. So viewers, that's what we have, and you see it's not a big deal to find. But now you realize that we are bringing in another concept of area of regular shapes. But like I said before, we can also get the area under this straight line by simple integration. And let me show you something here, if how it's going to come. So if you want to get the area, this area here, we got it by using a triangle, but some viewers may want just to use it using integration, all of them. So I'll say that this one here will be the integral of 0 to 3, so 3 is here, 0, and this one is x, so we'll just say x dx. So if you integrate this one, it will be x is the same as x power 1, so 1 plus 1, it will be half x squared, 3, 0. So this will be a half into 3 squared minus a half into 0 squared. A half, sorry, this is a half also. So if you realize that if you do this, this is 9 over 2 minus 0. 9 over 2 should give us 4.5. So realize that sometimes I like in telling students to write the statement of what they should do. And the statement of what they should do here is, if you're using all these things, you can say is integral area of the required region, meaning area of this R here, should be the area of the curve, which is the bigger one. From here, everything, which is, the curve is 4x minus x squared dx, that is 3, 0, minus 3, 0, x dx. Now realize that if you follow this, then you start by doing 1. You cannot combine them in 1 because it will be long. When you look at this, it may be small, but sometimes you realize that it will be something, some minus something, then something here minus something, because you have upper limit and lower limit. If you don't want to use this, you can just say minus area of triangle. Or you can just say minus triangle. You can just say the formula half base times height there, if you don't want to use integration. But if you want to integration, this is the way to go. So you'll be dealing with this, you put aside. You deal with that, you put aside. Then finally subtract this one from this one. Then you have your answer. But I prefer students using area or regular shapes because it's much more easier to see than that. But sometimes people vary. Some prefer using these particular directed formulas. Others prefer seeing the shapes that they can be able to do. Let's go to the 6th example. Okay, viewers, let's move to this question 6, which says the diagram shows a sketch of a curve with the equation y equals to x into x minus 3. You can see it here. And the line y equals to 2x. And that is the line that we have here. We are asked to find the coordinates of points A and points B. We know that point A is an intercept. Point B is the point of intersection of two lines. So point A, let's start with point A. We know that at A, the value of y is 0. So if I take that curve, which is going to be y equals x into x minus 3, but I know y is equals to 0, so it will be 0 equals to x into x minus 3. This will be x equals to 0, or x will be equals to 3 here. So 0 is here, but 3 is here. So what I'm going to say that at A, coordinate A is 3, 0. That is coordinate A. What about coordinate B? At B, the two curves are intersecting. At B, therefore, at B, y equals to 2x and y equals to x into x minus 3 are simultaneous. So what we are going to do there, that if they are simultaneous, then it means that y equals to 2x and y equals to x into x minus 3. So if y equals to 2x, then I can substitute 2x where y is. So I say 2x equals x squared minus 3x. If I bring 2x to the other side, I will get 0 equals to x squared minus 5x. So if I factorize, say 0 equals to x into x minus 5. And I can say x equals to 0 or x equals to 5. We know 0 is here, so 5 must be somewhere there. So it means that the coordinate of B, x coordinate is 5. The y coordinate, we know that y equals to 2x, but y equals to 2x. So we'll say y, therefore it will be 2 into 5, which is 10. So the coordinate of B here is 5, 10. Now, viewers, we have determined the coordinates of A and B. Now we need to get the area. You realize that if we have to get the area, I can already see that the area under this curve is the bigger one, because this curve is above this curve. So what I'm going to do is that area of this one, the big area here is a triangle, and from here to here is 5. The y-axis up to here is 10. So what I'm going to do is that first I'll say area of triangle, which is the bigger area, is equals to half BH, which is equals to half times 5 times 10, and that will give me 25 square units. It is simple. So that area covers from here, point O, this point here, to this point, to this point. But you realize that in this point here, there's area that we don't need here. You need to take it out, and this is the area under this curve between limit A, which we got A was 3, where 3 here. So we can say at A here, x is 3. So between limit 5 and 3 and 5. If we get that area under curve, we will subtract it from here, and then we have the answer. So viewers, we have to get more space, and the first thing now I'm going to do, I'm going to say that the area under curve will be now 5, 3, in bracket, if I open this, is x squared minus 3x dx. So if I integrate this one, will be 2 plus 1 will be x cubed over 3 minus, that is 3 over 2 x squared, because x is 1 plus 1 over 2 here. If I do that, 5, 3. So the first thing is I substitute. First I substitute 5 for the upper limit, which is going to be 5 cubed over 3 minus 3 over 2 into 5 squared minus the lower limit, which is 3 cubed over 3 minus 3 over 2 into 3 squared. So let's deal with this one. This is 125. So 125 over 3 minus, this is 25. 25 times 3 is 75. 75 over 2 is minus. Down here is 27. 3 cubed is 27 over 3 is 9. 9 minus 3 squared is 9 times 3, 27 over 2. That's what we have. So if we move forward here, we'll get 125 over 3 minus 75 over 2. That is 4 and 1 over 6 minus. Obviously this I expect to be negative. 9 minus 27 over 2. It's going to be minus 4 and a half. So we are going to have here plus, which means it's going to be 4 and 1 over 6 minus answer, or 4 and 1 over 6 plus 4 and a half is 8 and 2/3. So viewers, what we have done here is that we have done this, and we know that this minus this minus, so it will be negative 1 times that, because we are opening bracket. So if you have this answer here, is for this region here, so we know that the area we got here was the area for everything here. So what we are going to do when we are going to subtract this area from the area of the triangle, which is 25 minus 8 and 2/3. So 25 minus answer should be 16 and a third square units. This can also be 49 over 3 or 16.33 square. So viewers, you see, it's not a big deal to work out these areas. We want to do the last example, that example 7, to see how we can deal with it. Okay, this is now example 7, which reads a straight line L with the equation y equals to half x plus 1, and that is this line here, cuts the curve with the equation y equals to x squared minus 4x plus 3, and that is, this is the curve here at points P. These points, the two lines, the line and the curve, intersects as points P and the Q. Use algebra to find the coordinates of P and Q. Now we have said that the point of intersection of these two lines, or the curve and the line, those two lines or curve and a line form, the two functions form simultaneous equations. So what we are going to do is, we're going to say y equals to x squared minus 4x plus 3, and y equals a half x plus 1. So these two equations are simultaneous at points P and Q. So it means that I can say this part here, because this is y, is equals to this y here. So I'll substitute and say, if I say x squared minus 4x plus 3 should be equals to y, where y is a half x plus 1. So if I collect like terms, I will get x squared minus, we know that negative 4x minus a half x, I'll get minus 4 and a half x, then plus 2, because 2 will come here, it will be 3 minus 1, which is 2, equals to 0. But I know that because this is a half, I can multiply by 2 to remove a fraction here. So if I multiply by 2, I'll get 2x squared minus 4 and a half times 2 is 9x plus 2 times 2 is 4, equals 0. So viewers, we have to look for the product here. This is 2 and times 4 is 8, product of 8, and a sum of negative 9. The two values should be negative 1 and negative 8. If you multiply negative 1 by negative 8, you get positive 8, which is 2 times 8. If you add, you get negative 9. So I'll say 2x squared minus 8x minus x plus 4 equals to 0. Group these ones. This will be 2x into x minus 4 minus 1 into x minus 4 equals to 0. So this is 2x minus 1 into x minus 4 equals to 0. So here x equals to 0.5 or x equals to 4. So that's what we have in terms of x coordinates. It means that this one, the x value here is 0.5, and the x value on P the other side is 4. So what I'm going to do here is to get the values of y, because those are values of x, and I'll take the smaller function to deal with. So y is a half x plus 1. So when x is 0.5, I'll get a half times 0.5, which is, let's say 0.5, then plus 1. So y will be 0.5 times 0.5, 0.25. Then plus 1 is 1.25. Or if I have again y equals to a half x, where x is 4 plus 1, half times 4 is 2 plus 1 is 3. So y here is 3. So the coordinates here are 0.5, that is coordinate P. P is 0.5, 1.25, and Q is 4, 3. So we have got that. So these are the first part of the question A. So we have seen that the coordinate here, let me write them. We may need the space to use. This is 0.5, 1.25, and coordinate P here, Q, is 4, 3. So I want to clear this space and go to the second question. So if there's T and S are the x-intercepts, meaning that at T and S, y equals to 0. So what I'm going to do, take the curve y equals to x squared minus 4x plus 3, but where x, y is, I'll bring in the 0. So I'll say 0 equals to x squared minus 4x plus 3. Now product and sum. Product is 3, sum is negative 4, so it means it is negative 1, negative 3. So I can take 0 the other side by starting at x squared minus 3x minus x plus 3 equals to 0. This is x into x minus 3 minus 1 into x minus 3 equals to 0. X equals to 1, x minus 1 into x minus 3 equals to 0. So here x is 1 or x is 3. So we have said that where y is 0, that one we now take T will be 1, 0, and S will be 3, 0. So we have got the values of T here. T is 1, S is 3. 1, 3. So viewers, you see, in this particular steps, A and B is helping us to get limits here. You realize that we didn't know the limit here and here. Question A was able to provide that for us, now that we have this coordinate and that coordinate. The second part, we have been able to get this limit and this limit, which now has been obtained in part B. So what is going to give in part C probably is to get the area of the shaded part R. So C, find the area of the shaded region. Shaded region R. So if I were to distribute marks, I would say this part should give you 5 marks. Part A 3, part B 2. So let us see what this is going to give us. Let us see what this is going to give us. Let us understand this diagram here. This is a region here. If I take this line that is dotted here and that, we have a trapezium where this is parallel, the parallel lines. The height is from here to here. That is the area under the straight line, y equals to half x plus 1. And I said if you don't want to use trapezium, you can still use integration for this within limit 0.5 and 4. But I prefer to go for area of a trapezium, which is the area of the full region from this part to this part here, bound by those particular straight lines. So I'll go for area of trapezium, and that area there, area of a trapezium should be half h into a plus b. So half h into a plus b, h should be here, meaning if this is 4, this is 0.5, it should be 3.5 here. This one here should be 3, you already got it here, so this should be 3. This one here should be 1.25 there, so we can work with that. We're saying half times h, which we have said is 3.5 from this one to this part, 3.5 times a, let me take yes a, yes b. So a we have said is the y value of the coordinate, which is 1.25, plus b is the y value of that one, which is 3. So if I put that 1.25 plus 3 times 3.5 divided by 2, that is giving me 7 and 7 out of 16 square units. Let's see what we have done again. What we have done here is to get the area of a trapezium, which is from here to here, this one here, this one here. I said this one is the height, the distance between the two parallel lines, which is 4 minus 0.5, which is 3.5. Then we have said this y value here is equivalent to 1.25 from P, which is there. Then this one here is 3, the y value of coordinate Q, which is 3 here. That if you add that plus that, 3 plus 1.25, get 4.25 times 3.5. Then divide by 2, we get 7 and 7 over 16. Now we have done with that. Okay, now that we have got the area of the trapezium here, we need now to move on to get this area, the small area here. And the small area here is the area under this curve between limit 0.5 and 1. So I will get that area, let me call it area A, this one here, area A, is going to be given by the integral of, definite integral of 1, 0.5. And here is, the curve is x squared minus 4x plus 3 dx with respect to x. So that's what we have. Now moving forward, we just have to integrate. When you integrate this one, it will be a third x cubed, because it is 2 plus 1, then over 2 plus 1, minus 2x squared, because it is 1 plus 1 here, then over 1 plus 1, which is 2, so 4 over 2 is 2, then x squared, then plus 3x. 3x because 3 is the same as x power 0, 0 plus 1, it's just 3 over 1, just 3x, then the limits are 1, 0.5. So if we go forward to substitute, we are going to say this will be a third into 1 cubed minus 2 into 1 squared plus 3 into 1 minus this will be a third into 0.5 cubed minus 2 into 0.5 squared plus 3 into 0.5. So this one under the big bracket. So this will, if you look at this one here, 1 cubed is 1, so a third minus 2 plus 3 minus this will be 0.5 cubed divided by 3. So in fraction it is 1 over 24 minus 0.5 squared 0.25 then times 2. That is going to be a half. Then plus 0.5 times 3 is 1.5, which is the same as 3 over 2. 3 over 2. So you realize that this is 3 minus 2 is 1, plus a third is 1 and a third, which is the same as 4 over 3 here, minus here we have, let's have it here, 1 over 24 plus 3 over 2 minus a half. We get to do it again, 1 over 24 plus 3 over 2. We get then minus 1 over 2. We get 1. I do that is going to be 25 over 24. So if I do this, so 4 over 3 minus answer is 7 over 24 square units. So this one here is the area of this small part here. So the next thing we have to get the area of the other part, and the area of the other part will be, I want to tell you that we have already integrated, so I don't want to repeat the procedure because the curve is the same. So I'm just going to start substituting directly from here, and our limits are 3, 4. So I'll say a third x cubed minus 2x squared plus 3x. This is what we have for 3. The upper limit and the lower limit for that area. So we'll have here a third into 4 cubed minus 2 into 4 squared plus 3 into 4 minus if we substitute the lower limit, which is a third, into 3 cubed minus 2 to 3 squared plus 3 into 3, close that. So if we sub the first one, 64 over 3 minus, this is 16 times 2, 32 plus 12, then minus 3 cubed is 27 over 3 is 9, minus 9 times 2 is 18 plus 3 times 3 is 9. So this will be, let me do it, 64 divided by 3 minus 32 plus 12. We get 1 and a third. This 1 and a third minus 9 plus 9 is 18, minus 18 is 0, so everything here becomes 0. So the area there is just 1 and a third square units. Now we have got the area of this part here, we have got the area here, it's the part here. Now we said that we need to get the area of this R, and the area of this R is the area of the trapezium that we had here, it is here, minus this area minus that area. So I'll say this is the area here is 7 7 and 7 over 16 minus 7 over 24 and minus also 1 and a third. So this is 7 and 7 over 16 minus 7, 1 and 1 and a third will be plus 7 over 24. We get 1 and 5 over 8. So 7 and 7 over 16 minus 1 and 5 over 8, we get 5 and 13 over 16 square units. So viewers, the area of this shaded area region here is 5 and 13 over 16. You see this one was long. We first of all tried to get the area of the trapezium. We got it here. We went to this area here, which was given down here from this part. Then area B on the other side, we did it here. We got the answer here. Then I added this area and this area. That is this one. You see that and that, and this one. Then we subtract from this one, 7 and 7 over 16. Minus that, we get 5 and 13 over 16. So viewers, I want to give you the final idea about this one, which is area between two curves. We are doing the last part of this particular area, and we are now looking at the area between curves. Now, area between curves can take different shapes. Probably you can have shapes ranging this way, where you are told to find the area here. And in this case, sometimes the examiner will not give you the limits. So it's up to you to use simultaneous equation to be able to find the points of intersection of these two curves, maybe fx, gx, so that you get those coordinates. After you get those limits, you know that the upper one will be this, subtract this one, because the area under this one between these limits covers everything here, and the area under this one covers only below this one. So it will be the upper one minus the lower one within the limits you shall have calculated. So if you find something like this and you have the function for the first curve and the function of the second one, do not ask for the limits. You can actually calculate the limits. You can have cases like this where the region that you're supposed to calculate, there is no intersection. So in this case, you are going to find the curves. One is here, another one is here, and the lines here, line x equals to 3, x equals to 1. So in this particular case here, they will give you the limits. But in this case, in such a case, you don't expect limits to be given. So we are just going to do one example. Other examples, please, you will try them on your own. In case you have any problem, please do not hesitate to contact us with a comment on the comment section. We can be able to help you. So this example here, where we are supposed to deal with the curve half x squared plus 1, and there's another curve here, 5 plus 4x minus x squared. Then we have the two lines, x equals to 1 from this region to this region and this one. So this region in this particular area here, let me give this area as R. Let me call it region R. So if I have region R, if I get the area under this curve from this point to this point, going downwards, I'm going to cover up to here. But the area under this curve will be only covering this one here. So it means I'll get this one here. I get the whole area up to this particular point. Then I get the area under this one here. Then I subtract this one from the whole area here to get the area region R. And that one means, first I want to deal with this, which is going to be area of the bigger area will be, if I give the sign of integration, and the regions is, upper limit is 3, lower limit is 1, that is 5 plus 4x minus x squared with respect to x. Remember that I'm starting with this one because this is the bigger one. It is the one that we on the upper side. This one will have to be subtracted because the area under this one is what we need to subtract. So if I integrate this one very quickly, the integral of 5 should be 5x, because it is the same as 5 times x power 0. Then we add 1, we divide by the new power, which is 1. So 5x plus 4x. We know x is the same as 1 plus 1 because x is power 1. So we add 1, that's 2, divide by 2. So 4 divided by 2 is 2. Then this is x squared. So 2x squared minus, we know we add 2, we add 1 to the power here. So it will be 3, divided by the new power, which is 3, will be a third x cubed. That one with limits 3, 1. So if I substitute this one, I'll get 5 into 3 plus 2 into 3 squared minus a third into 3 cubed. That one minus the other part will be when I substitute 1, so it will be 5 into 1 plus 2 into 1 squared minus a third into 1 cubed. So if we do this 15 plus, this is 3 squared is 9 times 2 is 18. 23 cubed is 27, divided by 3 is 9. So minus 9 minus, this is 5 plus 1 squared is 1 times 2 is 2 minus 1 times that is a third there. So 15 plus 18 minus 9 is 24 minus 5 plus 2 is 7. 7 minus a third is 6 and 2/3. 6 and 2/3. So 24 minus 6 and 2/3, we get 17. 17 and a third square units. So that is the area, the bigger area under the bigger curve. We need to go to the area under the smaller curve. And the area under the smaller curve, if we start it here, it will be, that area will be still 3, 1, but now I have x squared plus 1 dx. If we integrate this one, we will get, this is 2 plus 1, 3. 3 divided by this will be 2 times 3, so it's 1 over 6 x power 3 plus x. That 3 here, 1. So if I substitute that one, I will get 1 over 6 into 3 cubed plus 3 minus 1 over 6 into 1 cubed plus 1. So this will be 27 over 6. 27 divided by 6 is actually 4.5. So 4.5 plus 3 is 7.5 minus, this one is 1 a sixth. 1 over 6 plus 1. So 1 over 6 plus 1 is just 1 and a sixth. So if you have 7.5 minus minus 1 and 1 over 6 is going to be 6 and a third. So this is 6 and a third. So this is the area below here, and this one is the area for the whole figure from this shape up to the x-axis. So if I want to get the area of the shaded region, it will be the area here minus that is 17 and a third minus 6 and a third. That will give us 11 square units. So viewers, you see, the finding that area is not a big deal. It's just patience, and then everything will be okay. If you have the case where, like I told you before, where the two areas, the two curves are intersecting, and you're asked to find this, I said that in this case no examiner will give you the limits, because they know since that line, the graphs are intersecting, you can be able to work out that particular area. But you realize that there are more complicated areas that you can deal with. For example, if someone gives you this kind of a problem, this kind of a problem, and then you are told to find this region here. You realize that this question may look very direct, but you need to do a lot. First, you realize that the area under this curve here is easier to get because, and it's going to be negative, you put it aside. That's area A. You can also get the area from here to here of the upper curve. You will get that area, but remember that the area you're going to put aside contains some part that you should remove here and another small part here. Then on the other side also, if you look at this area here, the other area, this area, after you get this area here up to here, get this coordinate and this coordinate by ensuring you get the points where they intersect. Get this point here, get this coordinate here and this coordinate here. And no, you can't get that because you have to get the area under this curve first. That's our intercepts. So after you get the upper area, which is going to be from here to here, subtract this one from this one, from the total area that you got from this one here plus this one here. It looks complicated, but patience, and you try to look at these things very carefully, you are finally going to see the answer. I said if you have this particular problem, get the lower one directly, put it aside as A. Get this upper one, the bigger one here, call it B. But that B, get A plus B. Note that this A plus B is not the final answer because there's a small area here, the small area here. Find them, then subtract them. Let me say this one is C, this one is D. Find that C and D and subtract from this, and you're going to be able to get the answer. So viewers, this is something that you just need to be patient with, and then the answers will come. Now that's the final point. The final part of this particular chapter is going to come in our next lesson, which is going to talk about how to apply integration in kinematics, in other words, moving bodies. Now finally, viewers, we want to urge you to subscribe to our channel so that you can support us also, even as we support you to learn from home. Thank you very much.